Hello, my name is Jason Adams. I am the founder and owner of MantraWorks. And sometimes people wonder what goes into making tensor rings. So in today's video, I'm going to talk a little bit about all of the tools and equipment that is needed to make a tensor ring. So here we go. If you want to make one of these, this is what goes into making our tensor rings. So first of all, you'll see way in the back here, I have a bunch of rolls of copper wire. We make rings out of copper and argentium silver, but the copper is primarily what we work with. So you're going to need a lot of copper, and we go through a lot of it here. So I buy them in rolls so that we can go, so that it works more efficiently, I guess. It's cheaper price, so we can at least help us keep our prices down. So the first thing, you're going to need to roll out a long strand of copper wire, and you're going to need something to cut the wire. So you'll need something like some of these clippers, depending on the size of the wire. And I also have, which you can't see in the camera view, but I have a bandsaw. So for the larger um, 2 gauge copper wires, we can use the bandsaw. These work pretty well for 8 gauge or so, but when we're getting into the 2, 4, 6 gauges, the bandsaw can work faster because it's an electric machine. So we'll use those to cut. So okay, we have a piece of wire. Then you're going to fold it in half, and you'll put one end of it in a vise, and then the other end you're going to put in a drill. So some of the drills we use here, this is a heavy duty drill, so we'll use this for the 2 gauge, 4 gauge, 6 gauge. This one can work with 8 gauge and smaller sizes. So depending on what size of ring I'm going to make, will determine what size of a drill that I need to use. But you'll put the wire into the end of the drill, and then with one end held together in the vise, and then with the drill, you'll just spin the wire to make that twirl, that twist shape. So those are some of the beginning tools that we use. Let's see. So, okay, we've twisted the wire. Now we want to make it to specific sizes. So then we'll use something like, you can use rulers. So I like to use centimeter, millimeters, as we can be a little bit more precise with those. So for the longer, bigger rings, we can use large rulers like this. I have a tape measure that goes out to, if I'm making a ring that's 10 feet in circumference, I can be more accurate with that. So it's a centimeter longer ruler or a tape measure. We can use something like calipers if you want to be really precise on the finger rings. This goes up to 6 inches. So smaller size rings, we can use calipers. And then I've made a bunch of these things. So this is basically a template for how long I want to make something. So this is the STU cubit length, 1/8 of an full STU cubit. But I just took this into a machinist and cut it down to what is it, 1,000th of an inch, and they cut the exact length, very precise, and then I welded on the end of it another piece so that I can put. Oh, this isn't exactly an example, but I could put a wire in that, and then I can know if I'm shortening this to get it to the right length, I can use this as a guide. So I have a bunch of these too that I can use, and this will help speed up my process. So instead of having to use a ruler, I can use this and I don't actually have to measure it. I can just see whether once it's flush with the end that that's the right size. But this cost me about $10 a piece to have a machinist cut this exactly the right size. So, okay, we're cutting the pieces now, and we can use another thing that you can use is something like using a file. So if you're using a ruler and you are trying to get it to the correct length, you can use a file to file the end. You can also use, which I have back here, if you can see that back here, a circular sander, or so it's a belt sander and a disc sander. So the disc part of it is what I use, but I'll turn that on and it's just a coarse grit sandpaper that you can sand the end of the wire, and that will just slowly take off some of the metal. And by using, I forget the type of sandpaper this is, but they're the most common one I want to say maybe is aluminum oxide. That one heats up pretty quickly, so it will actually make your copper heat up and discolor it, and it'll kind of, oh, I forget the term, the edges of it will start to curl over. So that heat kind of produces that effect. There's another kind of sandpaper that's a little more expensive, but it actually gets better results. That it keeps the heat, it minimizes the heat that gets built up, or the, I guess, whatever the friction that you're making, less of it gets converted into heat. So it minimizes how fast your copper will heat up. So it does a better job. So if you want to use sandpaper to get the correct lengths of your pieces, spend the extra money and get the higher quality sandpaper that will have less heat, that will cause less heat buildup. So let's see. I think that's kind of all that goes into, okay, we've twisted the wire. Now we've cut it to the exact cubit length that we want to work with. And now once we've cut it, we need to shape it into a ring. Essentially, we need to take the two ends of that wire, bring them back together so that we can weld them together. We can braze them or whatever process you're using, but we're going to reconnect those two ends back together to make that energetic loop connection, to finalize that connection. So how do we shape the rings? So these are some of the tools that I use. So if you can see back here, this is something that I made wood turning. This is a mulberry piece of wood, thanks to my cousin. Um, but I shaped this into a cone shape so that I can put, essentially, if I make a ring, and so I have a piece of wire. This is before I weld it. So I have a straight piece of wire. I'm going to take that wire and wrap it around this cone to kind of get it rounded, mostly formed, that shape. Then I'm going to take some tools like, a few different pliers that I can use. So this, I may use this one for larger gauge wires. So this one is large enough handle that I can grab 2 gauge, 4 gauge, 6 gauge, and kind of bend them and shape them. And I'll use this with 8 gauge as well. When I get into 10 gauge, 12, 14, and smaller wires, I can use something like, these are jeweler's pliers. These, you can either have them with a straight nose. This is a bent nose set of jeweler's pliers. But you can see with these, the inside, sometimes pliers will have these ridges. Uh, that gives you more gripping power. But the jeweler's pliers, if you get the certain ones that are flat on the inside, that way it doesn't mar and create little marks or imperfections on the pieces that you're trying to bend and shape. They also make um, plastic inserts that you can have on some pliers. So it'll be plastic that's actually making contact with the surface of your copper instead of metal. So that'll be even a little bit more safer for you not to put scratches and marks on your pieces. So pliers, we're going to use that to kind of bend the two ends so that they can fit flush together. So that once we have them flush, then we've got that surface where we can actually create that weld and weld it back together. So those are pliers. Um, so one other thing I was going to say before the actually welding process is when you have that wire and you've got it about ready to go, you actually want to clean that surface area. So I will use a Dremel sometimes, depending on what I'm making, but you can use a Dremel to clean off the ends of that wire. So you're basically kind of getting it to a high polish. And by cleaning that surface, it will, if you're brazing them, the braze will adhere or it'll fuse with your copper the best. So the dirtier it is, the harder it is for it to fuse together. So if you're somebody that actually is making your own rings and you kind of have been having trouble with getting your solder or the brazing rods they're kind of bubbling up on the surface and it's not actually like melting right into the piece, that may be an indication that the surface, the copper, is not 100% clean. If it's really clean, it'll want to flow. So you could use a Dremel or something like that to really clean up the edges. You can use sandpaper. So like 1,000 or higher grit sandpaper, something that's really fine, not coarse. That can actually give you a great surface um, to fuse to make it that kind of welding connection. But if you're using sandpaper, it is going to create little micro scratches. So if you really look closely, you're going to see little scratches in there. So sanding may not be ideal if you want your pieces to look great, but if you want them to be functional and for it to weld really well, that doesn't matter. The sand will clean the surface. So sanding is a good option. It just doesn't produce the most ideal results if you want something that looks like really high quality and no imperfections. So, okay, then it kind of comes down to let's let's talk about some of the equipment that you need to actually weld, braze, or fuse them together. So, I'm using brazing rods. So this is bare bronze. So 1/16 are a little bit thicker and 1/32 of an inch rods. So these are, I believe it's 3 feet long rods, 36 inches. So you're using a rod like this. You're dipping it into flux. Oh, what's the, oh, borax is generally what flux is made out of, borax. So um, one way you can do this is to if you find a can at a welding shop, drill a little hole in the top of your can, that way just large enough that you can dip your rod into the can. So the way you can actually adhere the flux to your brazing rod is heat up the end of the brazing rod, just warm it up. You don't really need to get it like turning color or anything. It doesn't need to be that hot, but just warm it up, get it in the flame a little bit, then dip it in and it'll stick to your rod. So you can automatically get that flux ready to go. You don't have to worry about putting flux on your piece. You can just have it on your brazing rod. That way you can do it faster and it'll be just as efficient. So brazing rods, that is one thing that's going to be needed. I have this here that I was just going to mention that I see a lot of people talking about using MAP gas or propane. So they'll have something that looks like this. And these can work if you're working with 12 gauge or smaller. You probably can get that piece hot enough to be able to braze it or to solder it, whatever kind of connection you're making. That can probably work. But the problem with this is the flame is not focused. So it has a wide flame. So if it's spread, that basically means that the heat, let's see. So here is the welding point on this ring. If I'm trying to put the heat specifically on that area, I want a really fine focused flame. With those tools, it just kind of shoots out. So you're getting heat on a large area of the ring, and you're actually decreasing the potency of your tensor ring by doing that. If you anneal the entire ring, you're weakening its potential. So if you can get a really fine, detailed, focused flame and just heat up that connection area, you're going to make the most potent ring that you possibly can make. So, okay, this is one option. This would be probably your cheapest option, but I don't recommend it. So if you want to make real tensor rings, this is probably a no. The next option would be one of these is a oh shoot, I'm forgetting the name offhand, but it's just a small portable jeweler's kind of setup. It is an oxyacetylene torch, um, but there's a specific name for this thing, and I'm blanking on what the name of that is at the moment. But if you find one of those are going to be kind of a smaller setup. So if you want to make smaller rings, it probably isn't um, going to work. It's not going to be powerful enough to make the largest rings. So that setup comes with a number of different tips. So this, uh, can't really see it on here, but the opening on these tips, there are 5 different sizes, maybe six. And so it goes from a very small opening to a larger, progressively larger tips. So the larger the tip, the more gas it can let out, so the bigger the flame. So smaller tips can be more focused. And I was talking about the more focused you can be, you will only put heat on the area that's needed. It won't disperse and heat up too much of the ring. So focus is good, but these are really tiny. So they're small enough to do really fine, intricate rings and things like that. But when you want to get into the bigger ones, you'll use something like this over here. So this is what I use for most of my pieces. So this is the same brand. It's Miller, but there's another brand name with it too. Um, I don't know if it's two companies that merged together. Oh, Smith. Oh yeah, so Little Smith torch. That was what I was trying to think of. The Smith's Little torch is what you would look up to find that setup. The Smith Little torch, and this is a Smith, I guess, full size or larger torch. So this one also has tips that you can, I want to say there's probably at least 5 different sizes. And this is the smallest, I want to say it's a 201. So they have 203, 205, 207. different size tips with this, and this is the smallest in this large version. So this one is focused enough. I can do the 2 gauge copper wire. So if I'm doing something, I don't even have any 2 gauge pieces here to show you, but it's really thick. Um, this can put enough gas out that I can still get a very focused flame, but hot enough to get the copper hot enough to actually braise. So if you're doing big pieces, this is what you need. And you're talking is this a 5 foot oxygen tank and a 3 foot acetylene tank. So these are oxygen and acetylene. Both of these are oxygen and acetylene setups for using those. So why do I use oxygen and acetylene? The acetylene can get it hotter. So usually with brazing, you need it hot enough to be able to melt the bronze, but not melt the copper. So the propane and the MAP gas can get it hot enough, but the acetylene gets it even hotter. So you can basically, if I am welding something, I can get in and out faster because it heats up faster. So the quicker you can heat it up, the less that heat will disperse throughout the ring and anneal the entire ring. Ideally, you want to only heat up the tiny welding spot that you can. The smallest spot that you can is ideal. So you could use something like this. These are third hand. You can get it like a jeweler shop. The third hands will hold your piece. So I've made a ring. Now I'm going to weld it together. I can put the ring inside this third hand. That's going to hold it for me, and then I can weld it. I'll put the flame here, the brazing rod, and work on that. So this can work for small pieces, and you can get maybe 2 of these set up so you can hold 2 ends. This is for small work though. A vise would be you can put pieces in a vise to it, I would use this for larger pieces, but that'll hold a large piece. And then I'll even use something like setting it on a cement floor, having some uh, steel plates on the ground, and I'll have that weighted down. So when I'm making really large, like 4 foot diameter rings or larger than that, I'll need to do that on the ground, and I'll have plates kind of holding it down so it'll hold the 2 ends like perfectly in place while I'm welding it. So I'll weld one side, flip it over, weld the other side. So those are some of the things that we need to weld them together. And I guess I didn't mention this. So this is a torch lighter. This just helps speed up your process. I don't know if you've ever seen people using a torch and a striker. So a striker will create these sparks. Like if you were out camping and you wanted to start a campfire, you could use something like this. So is this oh, I forget what that flint is. That what that is? Anyway, you could use a striker, or you could use something like this that is just a little more modernized, more efficient. So this is battery powered, but this you can just put on your table, and it has, once you press one of these down, you'll just take the end of your torch, and I haven't had this torch on today, so we'll see how this works. So it'll start the torch up pretty quickly like that. So I turn it back off. You can use that to light it really quickly. So if I'm making a flame, it's a good idea to have some safety glasses on. So normally I'm wearing prescription glasses. If I am working on something close, I can take my glasses off and just use these protection glasses. So that's a little bit about that equipment, and buying uh, gas for this is not cheap. So that's a big expense that goes into making tensor rings. So that's also talking about the safety glasses to keep your eyes without, like, putting any damage to your eyes by using these flames. They also make these kind of visors like this that you can, put a visor on, and then kind of this one I haven't used for a long time, so it's not really so great. But a visor can also be an option, but you need to invest in something like that if you're going to use a higher flame like that. And then it kind of comes down to, okay, we've made our rings now, we've welded it together, but now it's kind of not in a perfect circle. So we want to shape it, mold it into that perfect size. And I have these gloves here just to show you that these are metal working gloves, snap-on tools. Um, if you are doing a lot of metalworking, sometimes it's a good idea to have on some safety gloves. But we can do something like this, where we can put a ring. So say I have these, if I just made some finger rings, I can put a ring on there, and I'll take a hammer and shape it with hammers. So this is a, what is the, uh, dead blow. A dead blow hammer, rubber hammer. These are going to be softer so it doesn't make indentations and marks into the rings. But if you actually wanted to mark it up, you could use a number of these hammers too. You could use actual hammers. So I have a number of these different sizes. So I'm making finger rings and smaller pendant sizes. Then I can get into bracelet sizes. So these bracelets, you can put the ring on here and kind of shape the ring by using this. And then this will get in also bracelets. It'll get a little bit bigger, but this one is kind of special that I ground out a notch here so that when I'm making some of these tools here, when you weld one ring and then you interweave a second ring, and you want to make that you made one ring perfect, then you weld a second ring that's interlocked. You can put the two rings together, and I'll have one ring where they're kind of connected in this notch, this groove, so I can still make that second ring perfectly round. And then the third ring, I can do that too. So when we get into making this, the first three rings we can get, perfectly round by using something like this. Just regular safety glasses. And then this is another Durston tool. This you can just kind of check as a ring sizer. This mainly I am not using to shape them, but once they're finished, you can actually check the sizes on this. So you probably can't see on the camera, but this does have the ring sizes kind of lined up here through quarter sizes. So you can use that for shaping too. And the last thing that you can see here is what I had mentioned. This is another thing that I use for shaping rings, but I can put a ring once I've actually finished it, welded it together. I can put it on here and kind of shape the ring. So this kind of serves two purposes. I get it perfectly round, but it's also um, that weld point. When I've heated that up, it's annealed kind of in that small area, about an inch or so on both sides. So by work hardening the ring, by hitting it with a hammer, I'm actually helping to realign the crystalline structure in those copper molecules. So annealing it disperses the molecules. Hardening the metal realigns the molecules. So you actually do not want annealed pieces as tensor rings. You want something that's work hardened and um, the crystalline structure is back intact so that the energy flows, if that makes sense. So that's kind of a little bit about everything that is needed to make tensor rings. Thanks for watching. Sorry this was kind of a long video, but thanks for hanging out with us. The next video in this series, we'll talk a little bit about polishing and cleaning up your tensor rings, all the equipment that's needed to clean them and make them shiny and pretty. And for those of you that have tensor rings, some of these things could be how do you repolish the tools that you've had for a while and they've kind of gotten tarnished or discolored, I guess. How do you shine them back up? So we'll talk about that next. Thanks again.